All right, great. I'm Kyle. This is Jack, and we're going to talk about some
Oh,
air quality planning.
yeah, I guess we are.
So a little overview. We're going to talk about the EPA. We're going to talk about air pollution, different regulations that they've come up with, and appropriate and necessary comes up a lot. That's the main thing that the EPA regulations have to meet, and we're going to talk about cost and co-benefits. So this paper is mostly about mercury. It's a toxic metal. Is dangerous to humans in the form of methyl mercury, and you get that from burning fossil fuels such as oil or coal. And once that settles out, it can settle in ecosystems, and it's highly bioaccumulative, which means that essentially the larger the organism, the more mercury it'll have in it from eating smaller organisms. Quick timeline of air quality in the United States. In the 70s, Richard Nixon established the EPA, and they passed the first major Clean Air Act, and that mostly focused on regulating emissions from cars and other forms of transportation. In the 90s, you had Bush, who signed in different amendments to the Clean Air Act. These mostly focused on environmental issues, such as reducing ozone, and acid rain and urban air pollution. In the late 90s, the EPA did a utility air toxic study, which focused, which established if it was necessary and appropriate to regulate power plants and other industrial sources. In 2005, you had the Clean Air Mercury Rule, which aimed to limit emissions from industrial plants, and these two strategies, the first was a cap and trade program, and then the second was to, it required power plants to use maximum achievable control technology and limit pollutants. In 2008, the DC Circuit removes power plants from the Clean Air Act in their list of hazardous pollutants. 2011, that's when we had the mercury and air toxic standards, which is MATS, which is what we're basically going to be talking about today. And then in 2015, Michigan actually sued the EPA over MATS, stating that it wasn't appropriate and necessary. The Supreme Court ended up agreeing with them, and the EPA had to bring in back supplemental findings to dispute the ruling. And then eventually in 2017, the DC court indefinitely delayed arguments. So mercury and air toxic standards, like I said before, is MATS, originally finalized in 2011 to be added to the Clean Air Act. This was part of, Obama was in office at the time. They were just updating the EPA's regulations on industry. And MATS is all about limiting mercury and other air pollutants. The co-benefits of limiting mercury were one of the main points of this article, and they estimate that it would produce health benefits of $40 to $90 billion. In order to predict these costs, the EPA hired a consulting firm who's ICF, who used an integrated planning model, which is also known as an IPM. And this calculated the least costly way of meeting any electrical demand, conditional on the constraints that include environmental regulations. They considered a variety of options for complying with regulations. One was switching from fossil fuels to natural gas, and the other was just companies installing new abatement systems to limit pollution. And they also projected electrical output, energy prices, and emissions, and they calculated that for with a base case, so without MATS, and then one with MATS. So these are the costs that they generated, the primary costs that they generated. Essentially, IPM's discount rate was designed to represent a broad range of private sector decisions for power generation. Rates differ from discount rates used in other analysis in this RIA, such as benefit analysis, which each assume alternative social discount rates of 3 to 7%. So basically, it was just like what people are willing to pay. That was basically it. And so with a 3% discount rate, you're looking at $37 to $90 billion. With a 7% discount rate, you're looking from $33 to $81 billion. And again, base is without math, and the policy case is with math.
So the EPA study for MATS, they focused mainly on the IQ of children born to mothers exposed to recreationally caught freshwater fish in the U.S. that had mercury bioaccumulated into them. The EPA used census data to determine the average number of women aged 15 to 44, and they multiplied that number by the state rate fertility, and they multiplied that by the product. No, they multiplied the product by the fraction of households in the state with Angus total. And they divided that total number of people into 32 subgroups based on the distance from the freshwater where the fish was caught. The estimated average daily amount of that gave you the average daily amount of mercury consumption. They did this by multiplying 8 grams of fish per day by the average amount of mercury concentration in fish consumed by each subpopulation to get a mercury ingestion rate. Then they multiplied the daily ingestion rate by 12.5 using a ratio published in a toxicology study, then divided it by the average body weight for females under 45 pounds or 64 kilograms. Oh, under 45, 64 kilograms. That was a little over 140 pounds. Now, there's also a study. It turns out the cost of IQ went down with the increase of mercury. So there's also a study determining the monetary value of IQ points by determining the projected salary for a specific IQ number. Basically, if you had higher IQ, then you would make more money. So if there's less mercury, the children would be smarter, you make more money. The discount is the money that will not be spent in future, therefore money is earned. The co-benefits of MATS is the reduction of other air pollutants such as SO2, nitrous oxides, the particulate matter in general, CO2, and ozone. So there are a lot of concerns with this. 21 states have actually sued the EPA over MATS. If IQ is best metric to quantify, one other concern was if IQ was the best metric to quantify the effects of mercury, which no monetary value was calculated. Another concern was that no monetary value was calculated for the reduction in pollutants besides ozone and the particulate matter. There was also no monetary values were included for visibility or recreational use of lands. That being said, the estimated cost of increased visibility would be around $1.1 billion. And there's no quantification of various ecosystem benefits of the decrease of mercury. So last questions would be, how do politics play a role in regulation or deregulation of air quality standards for fossil fuel plants?
These are just questions that I thought of when I was reading this, so you can just, if anyone in the class would like to answer these questions, you can feel free, discussion points, whatever you want to do.
How are politics going to play a role in regulation or deregulation of air quality standards for fossil fuel plants? It's going to happen sooner or later. How do you determine value between private industry and citizens? Why were the co-benefits of changed fuel types not calculated in costs?
Yeah, so they mostly just looked at the co-benefits of reducing mercury and what if everyone switched to natural gas or solar or wind.
Right, so they didn't.
Those could have a lot of co-benefits as well.
Yeah. Which begs the question, what is the EPA doing? And then we're excited. Da, 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 da.